In this tutorial, I will teach you about the electrode potential. Suppose you have a piece of magnesium in a beaker of water. In the first diagram, you can see this is the magnesium ribbon and this is the water. What will happen? There will be some tendency for the magnesium atom to lose the electron and go into the solution as magnesium ion like this. This is the magnesium solid. This magnesium will lose the electron and itself will convert into the magnesium ion. The electrons will be left behind on the magnesium ribbon, and this magnesium ion will go into the solution. Now in the second diagram, you can see that on the magnesium ribbon there is negative charge, and around the magnesium ribbon positively charged magnesium ion is present. So you can imagine that there is a strong force of attraction between the magnesium ion and the electrons. Some of the magnesium ion have a very strong attraction with the electrons. So only those magnesium ion which have a very strong attraction towards the electron will reclaim their electron and stick back onto the piece of metal like this magnesium ion. This magnesium ion have a very great attraction, so this ion has picked up two electrons and rejoined the surface of metal. After some time, this system will gain the dynamic equilibrium. What is dynamic equilibrium? Dynamic equilibrium means the rate at which the ions are leaving the surface. Look at the diagram number 1. Suppose the rate at which the magnesium atom is losing the surface is exactly equal to the rate at which the magnesium ion is joining the surface of metal. If this rate is equal, then you will say that this system is at dynamic equilibrium. So after reaching the dynamic equilibrium, you have a constant charge on the magnesium ribbon and constantly positively charged in the solution. So you can say there is a difference between the positiveness in the solution and negativeness on the magnesium ribbon. This is the difference between the positiveness in the solution and negativeness on the magnesium electrode. This difference is basically, you can say, this is the potential difference, and you can measure this potential difference in terms of voltage. You can record this potential difference as a voltage. The bigger the difference between the positiveness and negativeness, bigger the voltage, like this. Look at this diagram. In this diagram, there are two beakers. In the first beaker, which is at the left hand side, magnesium ribbon inside the water, and in the second beaker, which is at right hand side, copper is in the water. So look, what is the basic difference in these two diagrams? You can see in the magnesium ribbon a lot of negative charges. A lot of negative charges, positively charged ion is surrounding the magnesium ribbon. And in the copper diagram, there is a less positive charge which is surrounding the copper electrode. What is the reason behind this? The reason is magnesium is very reactive metal. It will ionize more readily as compared to copper. It will lose the electron more readily. So a lot of electrons will accumulate on the magnesium ribbon. Copper is a less reactive metal, so it will not lose the electron readily. So there are less electrons on the copper metal. Okay. Now, what do you say? Where is the bigger difference between the positiveness and negativeness? In the magnesium electrode, you can see that a lot of electrons and a lot of positive charges are present. So in this case, you can say that there is a high voltage, and in the copper diagram, you can say that there would be a low voltage because there is a less difference between the positiveness and negativeness, and in the magnesium diagram there is a big difference between the positiveness and the negativeness. This difference is actually, you can say, this difference is called potential difference, and you will record this potential difference as a voltage. So this is the electrode potential. And what is standard electrode potential? This term is very important. Standard electrode potential. You can represent the standard electrode potential by E naught. When you will use this term standard electrode potential, it is must that if you have copper electrode, you will dissolve this copper, you will add this copper electrode into its salt solution like copper sulfate or copper nitrate. And suppose if you have zinc electrode, it is necessary that you will dip this zinc electrode into its salt solution like zinc nitrate or zinc sulfate. What would be concentration of this electrolyte? For the standard condition, the concentration must be 1 mole per dm cube. What would be temperature? For the standard condition, temperature would be 25 degree or 298 Kelvin. And if you are using any gas, the pressure of that gas would be 1 atm or 1 bar. Okay, thank you.